Hey, Jonathan here. This week I got to attend a two-day conference hosted by H2o, an innovative company which builds automated machine learning products. So in this video, I'm going to go over some of the event highlights. What does H2o actually do? Some machine learning basics, who are H2o products actually for, and a summary of some of the talks that I really enjoyed. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. So first up, one of the main reasons to go to this event were these 10 guys right here. So these 10 guys are Kaggle grandmasters. Now, for those of you who aren't familiar, Kaggle is the largest community of data scientists and machine learning engineers. Kaggle was originally put together by Google, and it hosts a number of competitions. Organizations submit their different problems where people in the community look to solve them to earn prize money or just to build up their experience in learning as well. So at the top of this list here, we have SRK from India. You can actually see SRK sitting on the end of this panel right here. SRK does some work for H2o. He helps them with their implementing some NLP strategies. And it was really great to see this group of guys here. Really, really brilliant, clever guys. But it was great to see that they came from a variety of different backgrounds. So before becoming Kaggle grandmasters, we have guys who came from originally like an accounting background. We've got one guy here who was originally from an Excel background. And the youngest guy here is basically a high school student. He is just 17 years old. So he started when he was 14. So that's this young guy over here, Mikhail. Absolutely brilliant. Very, very inspiring. So I think it really just goes to show that if you're really, really interested in something and you're willing to put into work for it, that you can pretty much achieve anything. So really, really great to see. Right, I just had to take a picture of this right here. Now, this was the type of thing they would serve up to us during the lunch and coffee breaks. So a bit of an upgrade from your kind of biscuits and tea. So if you're on a low carb diet, then really kind of hard to stick to. Right, so let's talk a bit about the H2o products. So this is a little screen capture from their website. As you can see here, they have some open source tools as well as some enterprise tools as well. So the two main tools are really the H2o product, which is basically builds machine learning ensembles. I'll go into that a bit more in a sec. And the enterprise product, which is Driverless AI. Now you've got a couple other things in here. You also have sparkling water and H2o for GPU. So I'm not going to spend too long on those because they're really just, they're basically just the same product, but sparkling water, basically what this means is that H2o works with Spark. Now, for those of you who don't know what Spark is basically a data analytics engine for big data. So this is basically when you have a data frame that doesn't fit into something like R or Python. And so that's actually got to be reasonably big because even with using something like R, I can manage say 10 million records on like a 16 gig laptop. And so before you start going up to something like Spark, which is using distributed computing and adds an extra kind of layer of complexity, you could probably just get a box running R or Python and add a bit more memory to it actually. Spark is actually a very useful tool though. And the fact that H2o has integration with it is fantastic. So let's take a quick look at H2o for GPU. Basically, all this means is that H2o will work with NVIDIA GPUs. And if you're not familiar, NVIDIA GPUs are basically graphics cards which enable you to play all your fancy video games. Now, it just so happens that NVIDIA graphics cards, which were originally designed for playing fancy video and computer games, are very, very good at doing calculations, the same type of calculations that you're going to be using in machine learning algorithms. So by repurposing these cards, you get very efficient, very cost-effective supercomputing type abilities, which is why NVIDIA has been one of the hottest tech stocks in the last few years. So let's talk a little bit more about H2o's actually core product. So H2o's open source product, does automated machine learning, but more specifically, it enables you to build ensembles. And so what is an ensemble exactly? Well, in this ensemble, you have several different people playing different instruments here. So with machine learning, that basically means that you have several different machine learning algorithms, which you're going to put together. So what H2o's open source product actually does is it tests multiple machine learning algorithms. It'll tell you how well they do and then combine their results to produce an even better result than perhaps any single one of them could have done on their own. Now, this is actually really useful for a number of different purposes. First of all, if you're new to machine learning, one of the challenges of learning it up is that there are many different algorithms, which are all quite abstract and reasonably complex in themselves. So if you're getting started, you might know one or two different algorithms, but then you might miss a few others, which might actually be a much better fit or solution to your problem. So one of the things that automated machine learning can do is it can take your data and it can test it with several different models to see which model is going to perform the best to answer your specific question. And the other thing you can do is basically combine several of these together to give you a better answer than you would have got just by using one machine learning method. Now, the way that I kind of like to think about this is, let's say that you're trying to get across town and there's lots of different modes of transport. You could drive, you could take the train, you could walk, cycle, or maybe even take a plane, although perhaps that's really not so really practical. Now, if you're trying to get across town, it's not always completely obvious which is going to be the fastest mode of transport. Because even though you can drive faster in a car than you can ride a bicycle, a car is going to get a lot more stuck in traffic. A train's not going to get stuck in traffic, but it has lots of different stops and the stations might not end up exactly where you need to go. So, by testing each of these, we can see how well each one performs. Now, the best option could actually be a combination of a few different modes of transport. Now, it's also worth to keep in mind that the most optimal solution may not always be the most practical one either. For example, let's say that you're getting a computer to figure out which would be the fastest route and which combination of all these different modes of transport would get you there the fastest. It could make assumptions that for every 10-meter stretch of road that you can't get to by train, you're maybe going to jump on a bicycle, which is perhaps not really that practical because of all the additional overheads of it. So the most optimal solution, the most practical solution takes the ideas from the most optimal solution and then sort of simplifies it to make it more practical for implementation. This again is what the H2o tool does for you with all of the different machine learning algorithms. So now let's talk about Driverless AI, which is H2o's enterprise commercial product. So Driverless AI, in short, is basically automated feature engineering. Now, if you're not sure exactly what feature engineering is, so 80% of the work is basically a combination of data pre-processing and feature engineering. So this is where the vast majority of time spent in AI projects actually end up. Now, data preprocessing is basically referring to getting all your data together, maybe pulling it out of different systems in different places, joining it together, doing some cleanup on it, all of that sort of thing. Now, the second part of this, feature engineering, is basically taking that data, which has been consolidated and cleaned up, and transforming it into a way that is going to be useful for the computers. More specifically, it's transforming the data in such a way that will enable us to get better results from the machine learning algorithm, because that's how they like to look at data. Here's a quick example here. So we have red dots and blue dots. And when they're in these two circles that we can see here on the left, it's hard for the computer to separate the two in order to classify them. So what we want to do is to do some sort of transformation on them to turn them into these two straight lines over here on the right. Here's a little slide on feature engineering. So coming up with feature engineering is difficult, time-consuming, and requires expert knowledge. Applied machine learning is basically feature engineering. So that's from Andrew Ng. Some machine learning projects succeed and some fail. What makes a difference? Easily the most important factor is the features used. So that comment is from Petro Domingos. Good data preparation and feature engineering is integral to better prediction. You have to turn your inputs into things the algorithms can understand. So here's another example using some time series data. So we have this time series data here. This is basically looking at sales. And what you can see here is that the data contains a lot of noise. So it's difficult to identify trends. Now this is sales for all of the stores within a company. If you could split those out, sales by store, then you're start to see some much clearer trends. And now this data actually starts to become a lot more useful. Let's take a look at what some of the feature engineering transformations actually look like with a data set. So here, up the top, we can see a raw data set. And we can see here that we have multiple different departments. And because of that, we have a duplication in the date field. So if you've ever worked with time series analysis before, you're probably familiar with the fact that you need to deduplicate your dates. Now, this often involves either something like aggregations, but again, when you roll all of your departments together, you're losing a lot of the detail. And the aggregated results may not reflect the more detailed patterns that you want to extract from your data. So some of the other columns here, we have weekly sales, and this is the historic weekly sales, and this is something we want to predict. Now, in order to predict this out into the future, usually what you want to do is look at some sort of trend. So to do this, what you take is some lagged versions of this as well, so you can start to build up that trend from the data. So in the second table here, down the bottom, we can see the transformed version of this. So you can see here that we now have these time groupings. This means that the time dimension can be unique for each department. So here we can see weekly sales 2 weeks ago, which is one of the features which has been automatically engineered by Driverless AI. And this will help us to detect a trend or a pattern which we can then use to predict future sales. Here's a little screenshot of what the H2o tool actually looks like. So I want to draw your attention to these three dials in the middle here: accuracy, time, and interpretability. So whenever you're dealing with a machine learning problem, there's generally going to be a trade-off between these three attributes. Now, you might think it's like, well, I just want the most accurate model. Now, the problem with that is that, first of all, as we mentioned in our previous example, that the most accurate model or the optimal model is not always the most practical one to implement. Now, the other challenge that we have is that A more accurate model is going to be less easy to understand and interpret. And the reason for that is because one of the things that takes place in the whole feature engineering process is that you're having lots of different columns, clusters of columns, groups of columns being combined together in different combinations to end up with a particular result. This basically means that the decisions made by the machine learning algorithm are based on a lot of different factors. Now, from an interpretability standpoint, what we really want to do is understand what was the key things that contributed to that decision. I have this quote from a builder friend of mine, which I really quite like. Price, time, or quality. Pick any two, right? So it just kind of goes to the fact that whenever you're building something, whenever you're solving like an engineering problem, is that there's always trade-offs. There is never a perfect solution. And so it's something that is always worth keeping in mind, because a lot of times people, really, they just want the best of everything, but there's always trade-offs. So in this instance here, we don't have cost, but we have time. That's how long the models take to run, and indirectly that is also a cost as well, because we're paying for processing time, or we're paying our data scientist time to wait for the models to run before we can get back a result. So time is a very important aspect there too. So now I'm going to go into some of the slides from some of the presentations. This is a slide from Dr. James Tromis, who's head of data science for the FX trading business at Citigroup. So here he talks about how your data strategy is key. And this is really what he's talking about here, is really getting set up and established to actually produce data science results. Without the core data infrastructure, it's hard to perform production data science. So basically what he's talking about here is being able to get access to all the data that you need to run your models in an efficient and automated way. Because if you don't have that in place, even once you've done your tests and experiments and you've got these models in place, you can't actually run any of them. This slide here talks a bit about the data science workflow. And you'll notice in here again that data preparation is approximately 80% of an AI project. So I think this is really where there's a very big opportunity for more people to actually get involved in the whole data science process, not necessarily just data scientists, because there's a lot more people that can actually do data preparation. And besides having the data wrangling skills, which are really good skills to have and build up, you also have here some of the domain expertise and stuff as well. So if you understand the data, if you understand what could be necessary to actually solve a particular question or problem, then you can really start to contribute to this as well. This leads on quite nicely to this next slide here, which is make AI a team sport, inviting everyone to participate and democratize it for the many. So this is really one of the goals of H2o, trying to democratize the whole data science process, because, well, really there aren't that many data scientists around. And your data scientist might be like the driver of this F1 car, but in order to support this, there's an entire team of perhaps 100 other people which are involved in getting this car to the races. So that's also very, very important as well. And the more people that we can bring to the table, the better it's going to be for everyone involved. So I like this little slide here. Machine learning interpretability, so hot right now. So one of the things that I kind of briefly mentioned earlier was machine learning interpretability. And this is important, again, for bringing people to the table, making sure that we actually understand how our models actually work and what they're doing. So it's important for testing and it's important for buy-in. So this slide here is showing a Shapley plot. And what this is basically doing is showing how each feature contributes to the decision that the algorithm is making. Now this does it at a global level as well as a local level. So you can kind of zoom out to kind of get the big picture of kind of what's going on, but then also kind of zoom into some more specific kind of cases as well, which is very important to actually look at both. So this presentation was talking about Data Table, which is a fantastic package written by Matt Dowell. So if you followed any of my other videos, you'll probably know that I'm a huge proponent of the Tidyverse standards for R. Data Table was another one of these standards that was built for R, which is now also being ported to Python as well. Now, I've not really talked about data tables that much, besides very kind of briefly mentioning them. So I'm gonna have to probably make another video on this another time as well. But I think data tables are actually a very useful and important library. Now, to give you a little bit more background, one of my best friends who originally taught me how to use R uses a lot of data tables. Yet, if you were to teach anybody how to use R, he would teach Tidyverse. Why is that? Now, my friend works with very large data sets and runs millions of different simulations. Two of the key benefits of data tables is one, they're very fast, and two, they have quite a nice, concise syntax for expressing things. Now, here's the thing. Tidyverse is definitely slower than data tables, but not by very much. And the thing is, if your data is not that big, you're not actually going to notice a difference at all. Like I said, I still deal with datasets up to 10 million records using Tidyverse just fine. So the Tidyverse has some other advantages as well. So one of the things that I've been mentioning a few times here is the trade-off between different things like speed and interpretability, or accuracy and interpretability, and different things like that. So whenever you're dealing with an engineering problem, again, there's always different trade-offs. And so one of the things about Tidyverse is that it's a much more interpretable standard, and so is much easier to use. It also has a very rich library of functions for being able to express much more complex logic much more simply. And so where data tables is basically an upgraded, highly performant data frame, Tidyverse is an upgraded data frame plus an entire ecosystem of additional functions and standards for working with your data. So this is why I use and teach Tidyverse for everything, and only occasionally switch over to data tables when I need to increase the application's performance. So I took this image from Wildbook, which gave a fantastic presentation on some of the work that they're doing to help combat the extinction of endangered species. So some of the things that they're doing here is that they are using image recognition technology to actually individually identify different animals. So before, you used to have to put, say, collars on an animal, which means you'd have to sort of sedate them, put this collar on them. The collars were expensive. And now they can basically use the image recognition technology instead to track individuals, which gives them much deeper insight and gives them much more data on the populations of different species. So some really cool and some pretty amazing work being done there. So I really quite like this slide here. This was talking about, since computers are now able to beat chess grandmasters pretty much every time, what's the point in people even playing chess anymore? And so what they found is that since the introduction of AI chess, a lot more people have been able to get into chess and develop themselves up to grandmaster status. So since the introduction of AI, we now have more chess grandmasters than we've ever had before. The other thing they found was this, is that even though we've gotten to the stage where that a human can't beat a computer AI on its own, when you combine the human with the computer, so the human's intuition plus the processing done by the computer, then a human plus computer basically beats a computer 100% of the time. So I really like this because it's not really talking about how humans can beat computers, but really how computers enhance our own capabilities. Now, at the end of the day, AI, machine learning, computers, they're really just tools for us to be able to do more, to leverage our abilities. Just think of it like, say, a car. A person wouldn't run faster than a car could. But a car can help us get us where we want to go more efficiently and faster. So it's really not a competition at all. And that's how I think we should really be thinking about things like AI and machine learning as well. So that is my summary of the event put on by H2o. If you want to learn more about data or learn more about me, you can visit my website at www.datastrategywithjonathan.com. If you like this video, please give a thumbs up. Thanks for watching, and I'll see you next time.